Welcome to the exercises solution of mathematics for class 9 new syllabus latest edition 2020-21 KPK textbook board Peshawar. In this tutorial we will solve the questions of exercise 2.3 which is about the real number and complex number. But before going into the solution of exercise, let's discuss some background. So this exercise will be about the radicals and radicand. So the concept of radical and radicand is, suppose if we have under root a n, if that is a real number, and suppose if n is greater than 1 and it is a positive integer, then we can say that n under root a will be equal to a1 by a to the power 1 by n. Okay, where n is called the index of the radical. Okay, this symbol is called the radical symbol. Okay, it is radical symbol, and the number a, that is called the radicand. Okay, that is called the radicand, and this whole number n under root a, that is called the radical form of the nth root of a. Okay, so see, we have that n under root a will be equal to a to the power 1 by n. This is called the exponential form of the nth root of a. This is called the radical form of the nth root of a, and this is the exponential form of the nth root of a. For example, if n is equal to 2, okay, then directly it can be written as under root a, mean there is no need to write 2, and it will be equal to a to the power 1 over 2. And suppose if we have n is equal to 3, then here we will have 3a, and it will be equal to a to the power 1 by 3. Okay, similarly if n is 4, then the radical form will be this one, and the exponential form will be a to the power 1 by 4. So a radical expression is any expression containing a radical number, containing a radical, okay, whether it is a square root, cube root, or higher root. Okay, so for example, this is called the square root, this is called the cube root, this is called the fourth root. Okay, now see what is the difference between this. Suppose x square and what suppose x square is equal to 6, okay, and 16, and suppose this is equal to 36 under root, okay, sorry, 16 under root. So in the first we are asked what number square are 16, what number square are 16. So it will be either -4 or 4, and here under root 16 it must be 4. Okay, mean the answer of under root 16 will be only 4, and x square is equal to 16, it will be either -4 or it will be x will be either -4 or 4, because the square of both number will give you 16. Okay, so suppose if we have n under root a, okay, that is another form of the radical. So if we have n under root a, that suppose represent a real number, and for example if m by n is a positive rational number, then a to the power m by n will be equal to n under root a power m, or it will be equal to n under root a whole power m. Okay, this is another representation. And suppose if, for example, if m is equal to n, if m is equal to n, then we will have n under root a to the power n, and it will be equal to a. Okay, so and see, suppose now we have different properties we can say, are different characteristics of these radicals and radicand. So suppose if a is a positive number, suppose if it is greater than 0, then the nth root of this a will be also positive. Okay, for example, if we have 64, so it is a positive number, so if you take any root of this, it will be also a positive number. Okay, and suppose if a is negative, see, if a is positive, then its nth root will be positive. If a is negative, then n must be odd for the nth root of a. Okay, then n will be an odd number. If a is 0, suppose, see, the general form of it is n into a. So let's suppose, see, if a is greater than 0, then the nth root of a will be what? It will be positive. Okay, if a is less than 0, suppose if a is negative, then n must be odd. Okay, then n must be odd for the nth root of a to get the real number. Okay, suppose if a is 0, okay, then the nth root of 0 will be also what? 0. Okay, now we have the properties of the radical. So suppose if we have n under root ab, so it will be equal to n under root a multiplied by n under root b. Okay, this is the product rule of radical. This one is the product rule of radical. Similarly, we have the quotient rule of radical. Suppose if we have ab whole under root n, then it will be equal to a under root n divided by b under root n. This is called the quotient rule of radicand. Okay, difference between radical form and exponential form. See, if we have a real number a under root n, then it will be equal to a to the power 1 over n. So this is called the exponential form, and this is called the radical form. Okay, see, for example, n under root 3, so this is the radical form of 3. Okay, and see, 3 square, this is the exponential form of 9. Okay, how to transform an expression which is given in radical form into exponential form. So see, if we have n under root a that is in radical form, so it will be equal to a to the power 1 over n, so this is the exponential form. Or suppose if we have n under root a to the power m, so it will be equal to a m divided by n. So this is the exponential form, and this one is the radical form. Okay, how to transform an expression given in exponential form to the radical form. Suppose if we have a to the power 1 over n that is in exponential form, so in radical form it will be equal to this one. Okay, or suppose if we have m into n that is a to the power mn, it will be equal to a power m under root n. Okay, so this is the conversion from the exponential form into the radical form. Okay, now let's solve the question of exercise 2.3. So the first question is, write down the index and radicand for each of the following expression. So here we have no value of n is given, 6 to the power 1 over 2, and this one will be equal to 1000 to the power 1 over 2. Okay, this is 8 to the power 1 over 3. Here we have q to the power 1 over n, and this one will be 5 minus 6 a square whole cube into 1 over 2, or it will be equal to 5 minus 6 a cube a square to the power 3 by 2, and here we will have minus 64 whole to the power 1 over 3. So this is these are the exponential form of the given radical form. Okay, Question number 3, transform the following exponential form of an expression into radical form. So it will be equal to 3 under root minus 7. Okay, this one will be equal to x to the power minus 3 under root. Okay, because here we have n is 2. Okay, here that will be minus 8 to the root n, I mean fifth root of the minus 8. This one will be equal to y cube under root 4. This will be b power 4 under root 5. This will be 3x under root cube. So these are the radical form of the given exponential form. Now simplify the following. So here you can see that we can write this in the exponential form like this one, 125x to the power 1 over 3. Now we can write 125 is 5 cube and this is x is into 1 over 3. Now according to the product rule we can write it 5 cube whole 1 over 3 and x into 1 over 3. Okay, so this will be 3 by 3 and we will get what, 1. So it will be 5 and x 1 over 3 and it will be equal to 5x under root. Okay, 5x under root. So this is the solution. Sorry, this is not 5 into 3 mean third root of x. This is the solution. Okay, now for this one it can be written as 8 divided by 27 to the power of 1 by 3. Now it can be written as 2 power 3 divided by 27 is 3 power 3 whole to the power 1 over 3. Okay, or it can be written as 2 by 3 whole power 3 by 3 according to the quotient rule. So it will be cancelled and the question answer will be 2 by 3. Okay, so this is the simplification form of the second one. Also now for this one we can write it as 625 x to the power 3 y to the power 4 divided by 25 x y square whole power 1 over 2. Mean this will be the exponential form of the we can say the exponential form of the given question. Okay, now it can be written as 625. It will be it can be written as 25 square. Okay, this is x cube. Okay, see also we can say that 1x will be cancelled here, so we will get what, 2. Okay, and 2y will be cancelled here and here we will have 2, so it means that we will have x square and y square divided by 25. That is what, that is we can say that is 5 square. Okay, whole to the power 1 over 2. Now it will be equal to 25 x y divided by 5. Mean in each and every number we have square and it will be cancelled with 1 over 2, and now from this we can get 5xy because 5 will be cancelled here with 5. Okay, now from this we can write it as 3y minus 5 whole square. Okay, to the power 1 over 2. Now 2 divided by 2, it will be cancelled and we will get 3y minus 5. Okay, so that is the answer, 3y minus 5. And here you can see that 6 multiplied by under root 18, so it can be written as 18 to the power 1 over 2. Now see, we can write this 18 as 9 multiplied by 2 to the power 1 over 2. Now according to the product rule, we can take this 1 over 2 on 9 and 1 over 2 on this 2. Okay, so from this we can get 6. 9 is equal to 3 square, so the square of 3 will be cancelled with 2 and we will get what? 3, and it will be under root 2. Yeah, this will be equal to 18 multiplied by under root 2. Okay, now for this one we can write it is 54 x 3 y 3 z square, so whole power 1 over 3. We can write it like this one. Okay, now see, this 54 is equal to we can write it is 2 multiplied by 27, and 27 is equal to 3 cube. Okay, and here we have x cube multiplied by y cube multiplied by z square whole to the power 1 over 3. Okay, now see, according to the product rule, we can take this power individually, 1 over 3 and 3 cube whole power 1 over 3. Okay, similarly multiplied by x cube whole power 1 over 3 multiplied by y cube whole power 1 over 3 multiplied by z square whole power 1 over 3. Okay, now the 3 of this will be cancelled with each other and we will get 3xy third root of 2 and z square. Okay, so this is the simplified form of the given question number 4. Okay, so this was all about the solution of exercise 2.3. Thank you for watching. Subscribe the channel, comment if you have any question or suggestion, and share it with your friend. Thank you.